Find the solutions of differential equation second derivative of y with respect to suppose x plus first derivative of y with respect to x minus 2y that is equal to 0, and check if the functions are linearly independent. So first let us find out the solutions of the differential equation, that is second derivative of y with respect to x plus first derivative of y with respect to x minus 2 into y equal to 0. And it is a, we know it is a linear homogeneous differential equation with constant coefficients, and here the constant coefficients are 1, and here also the constant coefficient is 1. And to find out the solution of linear differential equation, homogeneous differential equation with constant coefficients, suppose the solution y equal to e to the power mx, then first derivative of y with respect to x is m e to the power mx. Then we will find the second derivative. The second derivative of y with respect to x is equal to first derivative of m e to the power mx, that is equal to m square e to the power mx. And if you substitute the value of the second derivative of y with respect to x here or in equation 1, and the first derivative of y with respect to x in equation 1, and minus 2 into y, that means y value is e to the power mx. If you put this value of y, first derivative of y and second derivative of y in this equation 1, we will get the second derivative is m square e to the power mx plus the first derivative is m into e to the power mx, so m into e to the power mx minus 2 into e to the power mx, that is equal to 0. So if you take common e to the power mx, then in the bracket you have m square plus m minus 2, that is equal to 0. But e to the power mx that is not equal to 0, because this is the solution of the equation. We have taken y equal to e to the power mx, which is the solution of the differential equation. So e to the power mx will not be equal to 0. So this term, that is m square plus m minus 2, this will be equal to 0. Suppose this is equation 2, and remember equation 2 is called auxiliary equation or characteristic equation, generally written as AE or auxiliary equation or characteristic equation. Now from the characteristic equation is a quadratic equation, and by using the formula for the quadratic equation ax square plus bx plus c equal to 0, the roots are minus b plus minus b square minus 4ac divided by 2a. This is the standard formula. So the root here, the roots are suppose m, that is equal to minus 1, because here the coefficient of m is 1, so minus 1 plus minus b square, that means minus 1 square, plus 1 square 1 plus 4ac, so 4 into a into c, that is 4 into 2, that is equal to 8. So this will be equal to 1 plus 8, 9, square root of 9 is equal to 3. So minus 1 plus minus 3 divided by 2. So if minus 1 minus 3, that is equal to minus 4 divided by 2, so one root will be equal to minus 2, another root will be equal to minus 1 plus 3, that is equal to plus 2 divided by 2, so that is equal to 1. So you have two roots, one is minus 2, another root is minus 1. Now the two solutions of the given differential equation, or the two functions of the differential equation, will be y1 is equal to e to the power mx, that means m value is minus 2, so minus 2x. Another equation will be y2, that is equal to e to the power m2x, m2 is equal to 1, so e to the power x. So these two equations are the solution of the differential equation, or this is called the functions of the differential equation, given differential equation. And in the second part we have to check if the functions are linearly independent. These function y1 and y2, whether they are linearly independent or dependent. As you know, to check the function whether it is linearly dependent or independent, we have to find out the Wronskian. Wronskian will be equal to, or if you have two functions, the Wronskian will be equal to w, that is equal to the determinant of y1, y2, y1 dash, that means the first derivative of y1, and the first derivative of y2. Here you have the first derivative, so first derivative of y2. So you find out the first derivative of y1. First derivative of y1, that means derivative of e to the power minus 2x, that is equal to minus 2 e to the power minus 2x, and first derivative of y2, that means derivative of e to the power x, will be equal to e to the power x. So we will check the Wronskian. If Wronskian is equal to 0, then the two functions are linearly independent. If Wronskian is not equal to 0, then it is the functions are linearly dependent. Now let us check whether Wronskian is equal to 0 or non-zero. Since y1 is equal to e to the power minus 2x and y2 is equal to e to the power x, and y1 dash is equal to, our first derivative is minus 2 e to the power minus 2x, and y2 dash, or the first derivative of y2, is equal to e to the power x. So if you find out the determinant, you multiply e to the power minus 2x with e to the power x, that will be equal to e to the power minus x, minus, here a minus, so plus 2 into e to the power minus 2x into e to the power x, so 2 into e to the power minus x. So if you add these two, it will be equal to 3 into e to the power minus x. So this is not equal to 0. So Wronskian is not equal to 0. So the two functions y1 and y2 are linearly independent. Thank you.